Hello everyone, my name is Pranav Nair and this presentation is a part of the graduate student video on an NLP resource task assigned to the people who have taken the course ENGL-681 Natural Language Processing taught by Professor Cecilia Arm at Rochester Institute of Technology. The topic of my presentation today is going to be sentence boundary disambiguation in Python using the pySBD package. So what is sentence boundary disambiguation? Basically, it means sentence tokenization. Given a huge paragraph or paragraphs of text, you tokenize the entire paragraph or split it into different sentences. So this is a preliminary or an underlying task, the output of which is then given to input to further downstream tasks like named entity recognition, machine translation, and co-reference resolution. Sentence boundary disambiguation is quite an important task actually, and a pretty challenging one. The challenges typically vary depending on the language of the text. For the sake of this presentation, we are going to focus on English language. And although there are a lot of challenges that exist in segmenting sentences from English, two of the most important challenges are the ambiguity which arises due to punctuation marks and the ambiguity that arises due to the type of the text or basically the source of the text. That is, if the text is from medical reports or legal documents or academic literature or social media text, etc. So in such cases, simply writing rules that consider splitting at these punctuations, question mark, exclamation, colon, semicolon, and period, is not enough. The common approaches to solve sentence boundary disambiguation include supervised machine learning, unsupervised machine learning, and rule-based approaches. And these are some of the references for each of these approaches. The common challenge in sentence boundary disambiguation, one common challenge or example can be that, for example, in this, a period can indicate an abbreviation or decimal point, an ellipse, or an email address, and not necessarily the end of a sentence. So, how do you kind of make sure that your NLP engine takes into account all of these different occurrences and splits the sentence correctly? That is one of the preliminary challenge. So this topic has been touched upon in one of our earlier lectures in class, and we saw the APIs called send tokenize present in the NLTK package that could segment sentences. In today's discussion, I'm introducing before you another package called pySBD or Pragmatic Sentence Boundary Disambiguation, which was introduced just recently, around 2 years back. So, what is pySBD actually? pySBD is a real world rule based sentence tokenizer package in Python. Rule based, we saw in the previous slide that rule based methods are one of the ways in which you can tackle sentence segmentation. And we'll see in the further slides why it is called real world. So, this technology was originally implemented in Ruby, and the pragmatic segmenter is the name of the API or the gem in Ruby from which PySBD has been inspired so essentially the authors of PySBD have ported the pragmatic segmenter from Ruby into Python and kind of modified it. The pragmatic segmenter originally was tested on the golden rule set. We'll see what the golden rule set is in the further slides. In addition to the golden rule set, PySBD has been tested using the Genia and the Opus 100 multilingual parallel data. So the Genius data is a biomedical data set, and the Opus 100 multilingual data consists of sentences from different languages. So in that sense, pySBD offers multilingual support. The installation of pySBD is pretty simple, can be installed using the pip install command. In addition to using it as an independent package, it can also be incorporated as a pipeline component of Spacey using the add pipe method of Spacey. This is generally the preferred method, and everyone is aware of Spacey by now, I guess. So it's preferred to kind of incorporate PySBD into Spacey for you while using. So some of the advantages of PySBD are that the first one, it's domain agnostic. I mean, we had seen in the previous slide that one of the challenges of SBD arises mainly due to the type or source of the text, or whether it is medical reports or legal documents or academic literature or a social media text. So PySBD has been known to perform pretty well irrespective of the domain from which the text originally comes from, or irrespective of the type of the text, whether it is irrespective of whether it is a report or a legal document, etc. The second advantage is it is non-destructive. It offers non-destructive segmentation. So this point is pretty much related to the first point, wherein uh, PySBD is able to correctly identify the end of sentences and not unnecessarily split it at abbreviations or exclamation or an interrogation, which essentially do not denote the end of sentence. So it is quite accurate. Third advantage is that it offers multilingual support. We'll see this in the further slides that apart from English, PySBD offers support for 21 other languages, and this was because it has been tested on the Opus 100 multilingual data. The next advantage is it is robust with 98% test coverage. Again, we will see this in one of the following slides, what is meant by a 98% test coverage and on which data it received this. And the next advantage is it's built by considering various domain edge cases. So this point is connected to the golden rule set, which we will immediately discuss in our upcoming slide. And the last advantage is that it has package development with test driven development to ensure robustness. So, test driven development is the software practice in which developers kind of write a test case first and then write the minimal amount of source code which will fail the test case, and slowly then keep on building upon this source code until the source code is able to pass all the test cases. So PySBD supports such kind of a test-driven development. Why is PySBD called real world actually? So PySBD is a real world out of the box pragmatic sentence tokenizer. So it's called real world because it is based on the something called as the golden rule set. So this golden rule set means it's essentially a set of tests which have been introduced in order to check the accuracy of segmenter in regards to edge case scenarios. So what this means is that there's a small backstory to this. The makers of the pragmatic segmenter had stated that much of the research that is being performed in sentence boundary disambiguation papers use the Wall Street Journal dataset and the Brown corpus from the Penn Tree Band dataset. The disadvantages, according to the author of this datasets, are first, these datasets are a little expensive to use. One needs to pay to use these data sets, and second, much of the sentences present in these data sets typically end with a period. That is, they are straightforward sentences that typically end with a period. As a result, like according to the author of Pragmatic Segmenter, a good segment, most of the segmenters do tend to perform well on these data sets because you are training over the same kind of pattern of sentence ending again and again. I mean, the edge cases do not seem to be taken into account, and that's what the authors say. Like, a good fragmenter should be one which is able to handle different edge cases, and not just split the same kind of sentences again and again correctly a large number of times. So, in order to account for these edge cases, they introduce something called as the golden rule set, and I have linked I've attached a link to this golden rule set. As you can see, these are the golden rules for the English language. Not just English, there are multiple languages as well: Burmese, Amharic, Persian, Armenian, etc. For English, we have a set of 51 51 rules, or basically 51 edge cases, and these edge cases kind of represent the different ways in which humans perceive sentence endings. For example, as you can see here, like it's basically a bullet, one dot bracket the first time, two dot bracket the second item. So a correct sentence segmenter should be able to identify this entire string as two different bullet points, as you can see here. So that is exactly what has been written in this golden rules dataset, like to treat this entire string as two different sentences or two different bullet points. So that's what golden rules is a set of similar such out of the box edge cases rules. So since it kind of takes into account these out of the box rules that humans tend to use in their daily life, and like since most of these rules tend to kind of include most of the sentence ending representations as perceived by humans, that is the reason why PySBD is called real world. It's more of a pragmatic sort of stuff and does not just kind of deal with sentences ending with period. It can handle edge cases. So the core component of PySBD is the segmenter API. As you can see in this snapshot here, you import PySBD and then kind of initialize the segmenter API using a few parameters. These parameters are, it has four parameters in total. The four parameters inside the segmenter API are language, doc type, clean, and charisma. So the language is basically a two-character ISO 6391 code, and typically is used to represent the language of the input text. Like you can specify EN for English, ES for Spanish, AR for Arabic. So there are 22 such languages which PySBD supports. The doc type parameter is set to none if you're using a plain text, or in case of text which has been scanned from PDFs using an OCR. The scanned text would typically include characters like /n /t /s, these tags. So if you specify the doc type as PDF, PySBD does take these tags into account and will not consider them as uh, as an obstacle for sentence boundaries. The clean parameter is used to serve as text pre-processing and text cleaning, and when set to true, it performs this task. The character span parameter basically will return the string indices of the tokenized sentences. So it's basically just the indices that it's going to return. So this is the so this is one of the so in one of the advantages, I had stated that PySBD has a robust 98% test case coverage. So this snapshot is a validation of that. Like it shows the accuracy of PySBD compared to other open source sentence boundary disambiguation packages in Python. And you can see that they were tested on the golden rule set and the Genia dataset. And amongst the all the tools, PySBD seems to offer the highest accuracy of around 98 percentage in GRS and 97 percentage in Genia. So it performs pretty much better compared to NLTK and even the dependency parser present in Spacey and Stanza libraries. So these are the set of languages that pySBD supports. There are 22 of them, and the pySBD was tested on the Opus 100 multilingual corpus test sets containing 2000 sentences per language. The accuracy is on these 2000 sentences. As you can see, the accuracy is pretty high for most of the languages, barring a few, which are Burmese, Kazakh, and Polish. Um, According to the authors of pySBD, the low accuracy is one of the main reasons for the low accuracy, especially for the Burmese language, is due to the data set being a little bit unclean. Unclean in the sense there have been multiple sentences which have been kind of merged into one. So that may be one of the reasons. As a part of my conclusion, I'd like to reiterate that pySBD offers high accuracy, around 98 percentage, irrespective of the domain of your textual data. And as of October 2020, it's already been used by 71 plus projects. It is extensible in a community driven way, in the sense that um, like the golden rule set is by no means complete, and can we can also add additional rules depending upon how humans perceive sentence endings. So we can also add additional rules in the future and thereby expand the golden rule set. And also pySBD can be extended to support multiple other languages and not just the 22 languages present in the Opus 100 multilingual dataset. So it is extensible in a community driven way. And pySBD is lightweight. Lightweight in the sense, at the core of it, it is essentially a set of regex and other rules which have been implemented. So there is no machine learning model per se which is present or used by pySBD in order to perform the tokenization. So it is just a set of rules. And at the same time, it does not make use of any external libraries. So that is what makes it extremely lightweight and easy to integrate with other software pipelines, like, for example, Spacey that we saw before. So here are some of the references. I've put up a link to the pySBD GitHub repository, and this is a link to the actual paper for this technology. And the third one is a link for the original library that was implemented in Ruby, called the pragmatic segmenter. So yeah, do try using pySBD yourself, and if you find it useful, kindly do not forget to give a star on the GitHub repo and cite pySBD. Thank you. So that was my presentation for this topic. Thank you so much. Now, before leaving, I'd like to offer you guys a small demonstration of sentence boundary disambiguation. And in this demonstration, I have compared the performance of two packages over a set of sentences that I have designed myself, and referring the golden rule set. So kindly note that by no means do I want to prove that the performance of one package is better than the other, and in no means am I biased to pySBD compared to other packages. At the end of the day, pySBD is also a scientific tool which can have its um, disadvantages, or probably imperfections, not disadvantages, sorry, imperfections. And yeah, so in this, demo, we are going to compare the performance of pySBD along with the sent tokenized module present in NLTK. So you can install pySBD using this command in Jupyter Notebook. Make sure to include this pipe sign. I have already installed it, so I won't be running this command. So here the next task is to import all the libraries, just three of them: NLTK, Spacey, and pySBD. So after you import the libraries, the next task is to instantiate the segmenter API. Here I have passed the language parameter equal to en, and I have set the clean equal to true. So it will automatically do the text cleaning if any is needed. And we store the API instance into a variable called seg segment. So in the first text, as you can see, contains two sentences. Abbreviations are used everywhere is the first sentence, and for example, Rochester Institute of Technology is abbreviated as RIT is the second sentence. On running this piece of code, you can see that sentence tokenizer got the first sentence correctly, but it split the second sentence into two parts. Like, for example, got split here, and Rochester is the second part, or the third part. Like the second part of this got split like this. But pySBD tokenizer seems to have tokenized this sentence correctly, returning two sentences as we wanted. So in the second sentence, if you may recollect, is the one shown in the documentation for pySBD. My name is Jonas E. Smith. Please turn to page 55. The original text was only till this part, page P.55. I have kind of expanded it to include that is page number 55 in the book. So let's see how our tokenizers perform on this text. So as you can see, the sentence tokenizer uh, split it into three sentences, and pySBD tokenizer has split it correctly, taking into account all the periods, taking into account the periods accordingly. I mean, wherever they belong to an abbreviation, wherever they denote sentence boundaries, have all been taken into account and split correctly. So this is performed correctly when compared to NLTK send tokenize. The third sentence is can be a little a challenging one, mainly due to the number of punctuation marks which are present over here. There is a comma, there is a single open inverted, there is a question mark, there's a period, there are periods again, and there are even brackets. So this is a challenging sentence. Let's see how our tokenizers perform. The sentence, as you can see, is: the police inspector asked, "Who are you?" The culprit replied, "I am the goat." In open brackets, that is the greatest of all time. Let us see how our tokenizers perform. So as you can see, the first part again was got correct by sentence tokenizer, but the second part in got split only till "I am the goat." That, and it has included the part from the parent, like a parentheses, as a third sentence, whereas pySBD tokenizer returns just two sentences as we had expected, as we had wanted actually. I mean, the first part being the police inspector asked, "Who are you?" and the second part being the culprit replied, "I'm the greatest of all time." So these two sentences have been split correctly by pySBD. Now in this fourth sentence, I have made sure to include a website link, and we also have the bullet points that we had talked before. Like we have two bullet points over here. Go to this website is the first bullet point, and second bullet point is fill in your details. So on running this text, You can see clearly that pySBD tokenizer has split the two bullets correctly once again. Like the first bullet was this, and the second one was fill in your details. Whereas sent tokenizer has split it into four different sentences. It has kind of taken these bullets as a separate sentence, accounted for this period as a sentence boundary rather than the part of a bullet sign. So in the fifth example, here I have included a different form of bullets. Like instead of a period, I have a comma with me, and I've also included a slash and character over here to demonstrate the working of the doc type equal to PDF attribute. So for this, I have initialized a new segmenter instance, language as English, clean as true, and the doc type as PDF, something I had not done before. So this should take into account the slash n and split these two bullet points correctly. pySBD should do this correctly. So as you can see, sentence tokenizer has NLTK sentence tokenizer has accounted for this as a single sentence, whereas pySBD has split it correctly into two different bullet points, ignoring the slash n. So here is one last example where pySBD outperforms NLTK's sentence tokenizer. Like this entire thing is a single sentence. My flight landed at JFK International Airport at 5 a.m. on Tuesday. So the whole thing is one entire sentence with only the last period indicating the sentence boundary. So essentially, a good tokenizer should leave this text untouched. So let's see what happens. As you can see, uh, NLTK sentence tokenizer has kind of got this incorrect, whereas pySBD was able to not segment it at all, denoting that it was only a single sentence. So, given all the examples that I have demonstrated before you till now, might have given you enough faith when you look at pySBD tokenizer, when you look at the functioning for pySBD tokenizer, it might have made you think that pySBD is the best when it comes to sentence segmentation. Unfortunately, we know that I have shown in the presentation that pySBD is 98% accurate. That means there are still 2% chances of it being inaccurate. So let us look at these 2% inaccurate cases where pySBD is not able to perform as expected. So this is an example where both pySBD and NLTK sentence tokenizer get it correct. Like I've just included two sentences, the first one containing an email ID and the second one being a normal sentence. And on implementing the code, both NLTK sentence tokenizer and pySBD tokenizer is able to split it into two sentences. So here is an example where NLTK outperforms pySBD. Like this was totally unexpected when it came to pySBD, because I believe that one of these rules have been taken into account in the golden rule set, but it simply does not work as expected. So the sentence over here is, I'd love to see Junior NTR essay the protagonist's role in a film directed by SS Rajamouli, comma, once again. So on running this piece of code, so basically this entire text is one sentence, and all the periods indicate abbreviation, and the comma indicates manual pauses that one should take and not essentially the end of a sentence. So on implementing this, you can see that NLTK's sentence tokenizer left it untouched. That is treated it as a single sentence, whereas pySBD tokenizer failed here. It kind of split Junior and NTR as two different sentences. So, as I said, it is a tool. It can have its imperfections. Now, let us look at those examples where both pySBD and sentence tokenizer NLTK have not been able to, get the tokenization correct. Like this example, I have taken from the Stack Overflow link present over here. So the sentence goes like, during 2003, we improved our core focus on customers in the regions outside the US, period. As a result, several agreements were completed, period. So there are two sentences, and on running this piece of code, you can see that both NLTK and pySBD considered this to be a single sentence and not two sentences. This is quite an interesting case actually, because you see this period over here after S. This symbolizes two things actually. First, this is a part of the abbreviation U dot S dot, which is typically the way we abbreviate United States. At the same time, second, this period also indicates the end of a sentence. So it is serving as a sentence boundary as well as an abbreviation. So I believe that is the reason, or probably, that is a case which may not have been accounted for while building the library, or probably in the golden rule set. But like in the golden rule set, if you open, you should still see, examples of U dot S dot being incorporated. So it seems to have been incorporated, but for somehow, I don't know for what reason, the segmentation doesn't occur properly when using pySBD. Like so for if, like, like I already explained the ambiguity, the period the period representing two parameters. So in order to solve this, like if I kind of just add another full stop after the US, like, now technically the one dot stands for abbreviation and the other dot stands for a sentence boundary. So now if I tend to run my script, you can see pySBD got this correct this time. Like it split it into two sentences. During it stopped right at this point, the US point, and it started off a new sentence from as a result. So weird, I know. This makes sense technically, but not linguistically. So yeah, this is the edge case not handled by pySBD or NLTK. The second limitation is quite similar to the first one. The only thing being that after US, this time we have another abbreviation, which is Mr. So again, like if I kind of run this piece of code, you can see that both the tokenizers are not able to tokenize this sentence. And I believe this is the same reason for it. Like the period symbolizing the end of a sentence as well as the part of the abbreviation. Again, if I add one more period over here and run it, pySBD gets it correct this time. So it's just a small kind of an ambiguity which, none of the tokenizers seems to account for. And the third limitation is basically the rule number 18 from the golden rule set. So the authors of Pragmatic Segmenter have stated that none of the segmenters that he tried were able to segment this statement properly. And we will see that even pySBD and NLTK sentence tokenizer both are unable to kind of solve this. So let's look at the text. The text is, at 5 a.m., Mr. Smith went to the bank, period. First sentence. He left the bank at 6 p.m., period. Second sentence. Mr. Smith then went to the store, period. Third sentence. So there are three sentences here. And on running this code, we can see that NLTK was able to tokenize the first sentence up until bank. Then it left the remaining two sentences untouched. Whereas PySBD seems to have correctly tokenized the second and the third sentence as well as the first sentence, but it has unwantedly tokenized the first sentence further into two parts due to this period mark present over here, which is a part of anti-meridian. So yeah, this is the golden rule 18, which none of the tokenizer seems to have got it correct till now. Like a small modification which can be made is that after this a dot m dot, if I put a comma to indicate a slight pause, that is at 5 a.m. Mr. Smith went to the bank. If I kind of read it that way, that it makes sense linguistically. At the same time, PySBD is able to tokenize this sentence correctly into three different segments. So that I yeah, so that was just a workaround for this. But then again, it kind of should be able to do it without the comma as well. So that was all my presentation was about. I really hope that I was able to introduce something which you guys can even try and use in your next projects, and something that from which even you guys can reap a lot of benefits. If you liked this tool, do consider using it and consider giving it a star on the GitHub repository and cite it wherever you use it. So that was all my presentation was all about. Thank you so much, everyone. Have a wonderful day.